I'm Fumiya Kobayashi from Shibata Institute of Technology. Our research topic is Brain-Computer Interface (BCI), which is a technology that reads users' information from human brain signals like electroencephalogram (EEG) and use it to control external devices. BCI is alternative communication tool for paralyzed patients. One way to realize BCI is to use event-related potentials (ERPs) elicted by selective attention to specific sensory stimuli. Until now, visual stimuli have been mainly used as sensory stimuli on BCI. However, BCI using visual stimuli limits the user's activities because users should gaze at the computer display during operation. In comparison, BCI using auditory stimuli does not require gazing at a display, so the burden on the user is small. However, the amount of information detected by auditory stimuli is smaller than that by visual stimuli, and it is difficult to increase the number of selected classes. We thought that the amount of information provided by the BCI using sound stimuli could be increased by changing the location information of the sound sources. In this study, we investigated ERPs elicted by selective attention to the tone sequence moving around the visual sound space. Here is the experimental method. First, I explain the stimuli. Three different sound sequences were created used in the experiment: direction condition, frequency condition, and intensity condition. The sound and the changing attribute are shown in Table 1. The attributes of the sound change rapidly when they move in the virtual space. We evaluated the ERPs when we paid attention to this change. The experiment was concluded with 9 channels and a sampling frequency is 1000 Hz. Here are the results. The figure shows the waveform of synchronized additive averaging with the time when the sound was emitted at 0 seconds. A significant positive response was observed in the center of head for all three types. We can also see that the frequency condition saw the largest response. As a result of this experiment, ERPs were included by selective attention to a sound sequence moving in the virtual space. This study shows the possibility of BCIs in a virtual space using moving sound. That brings me to the end of my presentation. Thank you for attention.